Welcome to another exciting mathematics video brought to you by Upvision Concepts Academy. In today, we are going to be looking at sectors and arcs. Sectors and arcs. A circle is an amazing shape. When you have a circle and you divide it, you can create parts like arcs, sectors, and segments. Let me explain. This is a circle. We all know how a circle looks like. So an arc is just a piece of a circle, edge or circumference. So this is an arc. Let me say this is the center. An arc is just a point from here to here. This is an arc. And if you draw a line to meet the center and draw another line to meet the center, this is an arc. It's just a part of the circumference of a circle. Okay. So a sector is like a pizza sliced region bounded by two radii. So if this is arc, A and B is arc, a sector is just OAC. That is this particular region. It's a sector. So arc is AC. That is this point AC. And a sector is OAC. That is OAC. This is the region, by the way. So it has an arc bounded by two radii. So this R, two radii. While a segment is the area between a chord and a straight line. While the segment is the area between a chord and a straight line. So this is a segment. This shaded part is a segment. So you have the minor segment and the major segment. That's the other one. Okay. So now let's dive into the formulas that will help us to calculate the area of the length. Yeah, I don't think I need to check it. Okay, so now arc length. The arc length is of an arc depends on the central angle, which is part of the circle's total angle 360 degree. So the arc length, formula for the arc length is given as theta over 360 times 2 pi r. Why are we doing that? If this is the arc AC, so the arc length is just the length between A and C, and you need to find the circumference first and use this angle to divide the portion where the circumference forms the arc. So that is why we're having theta. Let's say this is theta, for instance. So arc length is this theta over 360, then times 2 pi r. So that's the arc length. Here, theta is the central angle and r is the radius. So this is the central angle theta and r is the radius. Okay? So if theta is in radian, the formula of arc length becomes this. Arc length is equals to theta r, where the theta is in radians. Okay, so area of a sector. Area of a sector now becomes area of a sector now becomes theta over 360 times pi r square. You see, we are using the area of a circle and multiplying by the fraction that will result from the angle sustained by the sector. Okay, so area of a segment. The segment is trickier because its area is the area of a sector minus the area of the triangle formed of the arc. Okay, so it's trickier. So if I want to find the area of this segment, for instance, now, I'm going to find the area of this sector minus the area of the triangle formed. Okay, so now let's do it like this. If I have this now, OAC. Now OAC, C is this point, A is this point. You understand? Now you know that OAC actually is the triangle. I'm just using, there's an arc that comes up like this. You understand? If I want to find the area of the segment, area of the segment is equals to area of the sector, which is the sector. Just watch where my hand is going. From here, this arc, and here. That is this one we have minus the area of the triangle, So there's a triangle that is here already, and this triangle, actually, you can get it by area of triangle. You can get it with this formula: half base times height. Half base times height, where the base is line AC, and the height is the one that comes from this center to this point. So it's trickier. I think the challenge will come from finding the area of the triangle. So quickly go into some exercise. Let me put one example on the board, so I'll look at it together. Okay, so let's quickly solve this. A sector, number one example, it says a sector of a cycle has a radius of 14 cm and a sector angle of 60 degrees. Find A, the length of the arc, and B, the area of the sector. Okay, so let's take pi as 22/7. Pi is equal to 22/7. Okay, so the sector of a circle has a radius of 14 cm and a sector angle of 60 degrees. Find the length of arc. Okay, so we can just draw the circle for sake of visualization. This is the circle in the center. So this is the two radii subtending the arc. Okay, so this center, this arrow, the same thing. This one is 60 degrees. Okay, so they say we should find length of arc. So therefore, length of arc, the length of arc, which is the same thing as the circumference of the circle. That is the fractional part of circumference. So it is theta over 360 times 2 pi r. That's the length of the arc. The length of the arc is theta over 360 times 2 pi r. What is theta? Theta is 60. It's given in the question. 60 over 360. 60 over 360 times 2 pi r. What's the r there? The r is 14 cm. 14 cm. Okay, so quickly, I'll just put 60 over 360 times 2 times pi times 14. By the time you complete all this, it will give us length at 14.67 cm. 14.67 cm. All right, so that's the answer. The next one, B, is for us to find the area of the sector. So, area of the sector now is the same thing as the fractional parts of the area of the whole circle. The big question says, find the area of the sector. Okay, so what's the area of the sector? Area of sector is theta over 360 times pi r squared. 60 over 360. 60 the angle, pi times radius is 14 times 14. So by the time you compute this one with the calculator, know that pi is 22 over 7. By the time you compute this with calculator, you have that the area of sector is equals to 102.67 cm squared. Please note your units, cm squared. The other one, the length is actually in meter, in cm, follow the convention unit here, it's in cm. And this other one is a meter cm squared because it is area. All right, so we'll look at finding angle, sector angle. Sometimes you'll be given a length of arc and they are told to find the sector angle. All these are just you knowing how to manipulate the equation, the algebra, look for what is missing, and use what you have to find what is missing. So quickly, we are going to be looking at this question that has to do with the finding the sector angle. Finding sector angle. Finding sector angle. Okay. All right, I have a question here. I'm going to put it on the board quickly. It says a sector of a cycle has a radius of 21 cm and an arc length of 22 cm. Find the angle theta of the sector in degrees. Take pi is equals to 22 over 7. Okay, so this is just a question that we will look at quickly. Now, using the formula for arc length, L is equals to what? Theta over 360 times 2 pi r. Now, what do we have? We have the arc length already. A sector of a circle has radius of 21. Okay, r is what? 21 cm. Arc length is what? 22 cm. So we have this, we have this. These are constants. So we're looking for this. So we just length is 22 is equals to theta over 360 times 2 times 22 over 7 times 21. So 7 here 1, 7 here 3. What do we have again? Okay, this 22, we cancel this 22. So I have 1 is equals to theta times 2 times 3, theta times 2 times 3, all over 360. 360 will go up. 360 is equals to theta times 2 times 3. 2 times 3 is 6. So theta is equals to 360 divided by 6. Theta is equals to 60 degrees. So that is theta. That is theta in the simplest form. Okay. So that is for finding the sector angle. So we also have a ratio of two sector. We'll consider that one. Ratio of two sector. Okay, let's look at, yes, ratio of two sector. Ratio of two sector. Okay. So the question here says, number 3, it says two sectors A and B have the same radius of 14 cm. The angles of the sectors is X sectors are 80 degree and 160 degree respectively. Find the ratio of their number A, arc length, and B, areas. Okay, so look at what happened here. They are giving us two sectors, A and B. So two sectors A and B. Let me do it. This is sector A. I'll call this one sector A. I'll call this one sector B. Two different sectors, A and B. They came from a circle. Remember, this is a circle that was chopped off. Okay, so they say two sectors A and B have the same radius, 14. So if this one is 14, this one too is also 14 radius. I've labeled the two of them, 14, 14. The angles of the sectors are 80 and 160 respectively. They are using this English respectively. It means you just follow it. Respectively means that this first one is mapping this first one. Second one mapping the second one. So A is actually 80 degree and B is actually 160 degree. So they say we should find the ratio of their arc length. So I will say arc length A. Arc length A is equals to, that's L, theta over 360 times 2 pi r. Now, what is the radius of A? Is 4. Okay, so arc length A is equals to this one, theta is 80 over 360 times 2 pi, r is what? 14. So this is for arc length A. Arc length B. Arc length B. Let me asterisk this one so I know what we are talking about. So arc length B, the theta is 160 over 360 times 2 pi r. R there is 14 again. You understand? So this is arc length B. So they say, what is the ratio of the arc length? So the ratio, let's denote the arc length as LA arc length A to LB arc length B. So this is what we're looking for. So if this is what we're looking for, we need to reduce this, we need to divide this by this. Divide this by this. You understand? When you're doing your division, first of all, look at all things that are common. They will cancel out. If this is common, it will cancel out. Okay, let me put it here. Arc length A. Okay, I will just this arc length A. LA is equals to 80 over 360 times, this is 28 pi. Make it simpler, 28 pi. Then arc length B is equals to 160 over 360 times 28 pi over 1. Now, because this one is here, this one is here, can cancel. This one can cancel. What I'm left now is 80 and 160. So LA to LB, that's the ratio, is equals to 80 to 160. And LA to LB is equals to 1:2. That's the answer. That's the answer. That's the ratio of the arc lengths. Now, let's look for the ratio of the area, and we'll call it quits. Ratio of the area. Okay, let me just clean this, erase these ones. All right, so for the areas, area A is theta over 360 times pi r squared. So area A is what? Let me call it A small a. So what is A in A? Theta is what for A? Theta is 80 degree over 360 times pi times what is that is 14 square. Then area B or A subscript B is equals to theta for area B is what? For sector B is 160 over 360 times pi times 14 again square. So to look for the ratio of the area, so the ratio of the area is area A to area B. Area A to area B. Area A is this one. So it is area A is equals to 80 over 360 times pi 14 square. Then area B is equals to 160 over 360 times pi 14 square. Now again, this one will cancel this one. This one will cancel this one. What I'm now left with is 80 to 60, 160. So area A to area B is equals to 80 to 160, which is the same thing as 1:2. So both parameters, area A and area B, ratio is 1:2. Arc length A to arc length B, the ratio is 1:2. So we'll stop here for today. I want us to click like for this video and subscribe if you are new to the channel. Thank you for watching.